Good morning, everyone. My name is Ibuka, and I'll be your host for today's webinar. And so I have Olufemi. I have a couple of people here already. Please, if you can hear me, just indicate by raising up your hand. There's an icon by your screen. Okay, so you can all hear me. Okay, that's nice. Okay, so today we're going to be talking about software-defined networks. Hopefully, other people join us as we continue, and we just have 45 minutes to talk about how to optimize your IT networks for agility, and business responsiveness. Yes, so I have here with me Obina Samuel. He's a systems engineer at Signal Alliance, and he'll be the one to anchor this session. Feel free to ask your questions. There is a question icon somewhere on your screen. Feel free to ask questions, stop us at any point in time if you need more clarity on anything, and hopefully we get to enjoy the next 45 minutes. So I welcome Obina Samuel to continue.
Yeah. Thank you very much, Abuka. Good morning, everybody. My name is Obina Samuel Emesoroye. I'm a systems engineer with over 7 years of IT work experience. I've moved in between different space. I have been in the core networking part, then also the compute and storage portion as well. Because your systems integrators, so you cannot per se specialize. So we move in between a lot. Without further waste of time, I will get into the business of the day. And the essence of today's session is to talk about software-defined networking and how that can help you achieve optimization of your network to be responsive, so your business can be swift and rapid in this ever-changing world. So, great. My bad. The session objective is here two major things. If something is supposed to optimize your network, if something is supposed to optimize your business so that you're more agile, you're more flexible, you're more responsive, then you have to understand what that thing is before you now begin to look at understanding how those things will really achieve what we have promised. So first, we need to understand what SDN is. SDN is a tool that we can use to achieve business agility or business responsiveness. Permit me to use analogies to explain really technical concepts. I think with analogy, we will paint a very vivid picture in our minds so that understanding can be achieved. So this is a non-technical analogy of SDN. Imagine you're in a system, in a road, it's a busy road. Let's imagine this picture in front of you is Third Mainland Bridge. Both ways, lockdown, typical scenery we were experiencing, say, 4 or 5 months back before they optimized the road. Then we had cars, buses, bikers, pedestrians passing over the road. And those different things, the cars, the buses, the lorries, the tankers, all represent different things in the network. So the road is analogous to the network, the vehicles plying those roads, analogous to the data streams that passes over this network that you are provided. And you will have a lot of keeping up to do with traffic lights, signs, and laws governing the roads. How to ply the roads and how not to ply the roads, which routes are one way or which is not one way, when to move, obeying the traffic laws, and when not to move, and enforcing those laws. Then imagine that, of course, that's all scenery. When who passes what and where represents your router or your typical switch. If that is the case, then it therefore means that, like, what the traffic light does to our roads or the law enforcement does for our roads is the same thing as what the routers and the switches will do in the network. But still, it is not optimized. Road has a lot of issues. Now imagine that there is a master traffic planner, the law enforcement, whoever, is able to really plan how traffic runs in a city, in a given instance, typically Lagos. The difficulties optimizing flow of traffic, smooth flow of traffic. All of that, this master traffic planner has to take into consideration, and trying to probably add new lanes on the roads, prioritize some particular traffic, prioritize some certain category of vehicles, probably the ambulance system. All of this has to be done by a human being. So back to the network, that person is going to be your network admin. Your network admin is going to be the master traffic planner, in that it's supposed to know when to add additional switches and additional routers, or when to add additional routes on the routing table of the router, when to create a new route rules, and when to filter some certain traffic path. All that is done by the network admin. But it could be different. It could do it differently, whereby the roads are smart enough, all the routes are smart enough to know when to move from where to where. It sounds very impossible with the physical analogy that I'm giving, but logically, please, I think it is very important for us to understand how that can tie into our business and how we can utilize that on the network. The concept I've painted to you is the typical scenario of how the current network architecture we have running works, where you have a system admin that adds rules, prioritize traffic. All of these tasks are done manually. But then how does SDN come into this? Wikipedia's definition of SDN is an approach to build a computer networks that separates and abstracts elements of this system. What does this really mean? We understand the functions, the core functions of a typical router or a switch. Move packet from one point to another point. So if that is the case, it therefore means that three things have to be running on the router or the switch. There will be a control plane, there will be a data plane, and there will be a management plane. The control plane is where certain things happen. The routing protocol runs off of the control plane to help the data plane navigate the best path and give us maximum uptime. Typical control plane protocols are STPs, spanning tree protocols, and things like that. Forgive me, I don't want to go too technical, but I have to say, give reference to a bit of technical detail so that we can better grasp what I'm trying to say. So if you are able to abstract, so in essence, SDN is being able to abstract the control plane from the data plane. What do I mean? The intelligence of any device, of any network device, currently as we have it, resides on top of that device. What SDN is proposing is to remove that intelligence and keep it into a central repository that all of the command and control happens there. Then the physical network device just does packet switching. These are instances or differences between what I mean by control plane and data plane. These are the two different categories. The management plane is not here because it's not so critical. So I'm trying to paint a picture in our minds. Currently, what we have is that every network device will have intelligence residing on it. But what SDN is proposing is that there are going to be three different layers. There's going to be the SDN application layer, software-defined network layer. There's going to be the controller layer, and now there's going to be the physical network devices themselves. The routers, the switches, the firewalls, the load balancers, and all of that. It therefore means that SDN is going to abstract the control plane or the intelligence off of all of these devices into a central location. Then you can leverage things like orchestration and automation to better manage your network. Now, why do you have to do all of this? Or why do we have to worry about all of these kind of concerns? The reason we have to worry about it is because before now, the network was just a file, more or less a file transfer system, where you will send mail into all you needed to do, or all you could do was to send mails, pictures, and send video files. You're sending video files, not particularly streaming. The whole idea of streaming started happening from the late 2000s, and therefore, and of course, video is a bandwidth hungry packet. All of these were not there before, but now, even moving forward, there are more devices, there are more applications that are more bandwidth hungry that were not there before that are going to be introduced into the network moving forward. Things like IoT, Internet of Things, and big data, the era of big data, will stretch the limits of your network. You will see the CPU utilization of your typical firewall rise up to as high as 100%. Reason being that the traffic those devices were used to traditionally are still running on the network, but yet there are new applications, there are new kinds of traffic that has been introduced. Typically, your IoT. It therefore means that your smartwatch, the wearable technology, your home appliances, and every other thing will come on board onto the network, which will boost the traffic rate. So you need an agile network that can accommodate all of these unforeseen or, well, progressive but bandwidth hungry applications and traffic. And that is what SDN is proposing. This is a typical, the distributed architecture that you see here is the typical way we have our network currently. You will have sets of devices in your data center. You will do your manual provisioning to provision servers and things like that. If you wanted to scale up or scale out, you would need to add a new well, top of rack switch to your server to your server racks and manually configure those devices. There is a lot of manual integration. You have to do some rule permitting some certain rules on your access list in your router or your firewalls and things like that. Those are still very, very manual, and that is how we are currently running the business. But some of us, or some organizations, have transitioned into the fabric-based architecture where they are consuming both cloud services and on-premise services, and it's closely knitted, but not as close as it could be. Now, the application-driven architecture is where SDN plays a very large role. So you're consuming cloud-based services, you're consuming on-premise based services, you're consuming IoT-based services, you're consuming your architecture has to be agile, resilient, and fault tolerant, has to be highly available. All of this has been hardwired into the fundamental architecture of SDN because of things like network programmability, but I don't want to go too much into the technical details. So this is understanding how that affects us, or affects, or what SDN has to offer our businesses. Responsiveness. Flexibility is a very big deal, especially in enterprise architecture or enterprise networks or SMB or anybody. You have to be flexible in the ever-changing world, and the pace at which your flexibility will be stretched will determine how far you go, how successful your business might be eventually. This is the era of disruption, and you need to be flexible to be able to adjust to all this level of disruption that will come your way. And SDN allows you abstract or move away from the traditional way of doing things that is so manual, that is so rigid, and allows you to leverage virtualization on the network. What do I mean? Please, I need you, if you remember, before the era of virtual machines, if you needed to typically instantiate an application or a service, say for instance, you needed to get FlexCube, or you needed to run some custom application on your premise. First, if it is custom, of course, you go for a typical configuration of servers and all that. You will have to dedicate one whole server to that application or that service. If it was Exchange, for instance, you will have to, if you wanted to run Exchange, you will have to get at least 3 servers or things like that, depending on the architecture, the best practice architecture that Microsoft will recommend to you. You would buy one that will be the CAS, one will be the hub, another will serve another purpose. Those, you're going to max out all those servers, even though you're not really maxing out the utilization per se, but all of those one application will sit on top of one physical box, in essence. But virtualization brought forth the idea that you could have a layer of software called hypervisor sitting directly on top of your bare metal, that's your physical server, that can accommodate several instances depending on the scale and size of the server, the physical server underneath. You could maximize utilization of that one box. You could have several servers and services running off one physical box that was not available before. That was what virtualization brought to the server or compute world. And we leverage it, and we leverage it well, to the point where the concept of virtual machine mobility, VM migration, became available. So we could do VM mobility. We could move a server from, say, for instance, if you had a data center, you had a main data center, and you had a disaster recovery site. So you wanted to do maintenance in your main data center. You could as well, just leveraging technologies like VM mobility, migrate that server or service from the main data center where you wanted to carry out your maintenance to the disaster recovery center with uptime. You're not going to experience downtime on that service, on that application, and you could migrate it over to the next data center, and that was and the speed was going to be very, very fast, depending, of course, on the bandwidth you have available on your infrastructure. Those were concepts that were not possible before, that were not available before, but those were things that came along with compute virtualization. Automation is another concept that SDN will bring. You could really leverage automation to make sure that you have a good and smooth sail of your processes. More than half of the times that we have to troubleshoot things, or we have downtimes in our infrastructure, be it storage, compute, or whatever, wherever, it has almost always been that a little bit of human error has brought about that downtime. But if you could automate those processes, whereby you minimize the level of interference, of human interference, and thereby, of course, drastically reducing your downtime with automation, and those things are quantifiable. Those are concepts that SDN has come to infuse into your networks. And of course, also, SDN gives you a good level of visibility. You have good understanding of who is doing what. Why? Because you have a central body that does the intelligence, that handles the intelligence in the entire architecture. So you will have, say, for instance, you have 7 firewalls, and because you didn't want to be locked down by one particular OEM, you had Palo Alto, Checkpoint, Cisco ASA, FortiGate, Fortinet, for instance, all running on your architecture because you are trying to be really, really fortified. But you will also need IT personnel that would have to understand all those different boxes. You will be lucky if you had one person that could understand or deploy all of that and manage those devices very well. But you might have to have multiple people that will do the policy management and maintenance individually off of those on those individual devices, on those individual different OEMs. But with SDN, because there is going to be a central controller, a central intelligence body, you could leverage concepts like API and speak directly to the boxes without really understanding the programming languages or the way you interact with those different OEM boxes, where the application itself would demand of the network its requirements to run smoothly, and the network in response would in real time adjust itself to accommodate the application to run smoothly. For those of us that are familiar with networking or that have networking background, the concept of quality of service. Let us imagine a situation where you could you will be able to dynamically, in real time, an application will come and request for a particular quality of service, will require a particular level of quality of service of the network, and the network will in real time deliver that. That drives speed, that drives agility, and that drives uptime, maximum uptime. So all of these that I've said, how can it improve your application performance? Just like I just explained, if you could have a dynamic quality of service settings in the entire architecture, in the entire infrastructure, from say your branch offices down to your data center, or from your branch A to your branch B, depending on the mission critical or business critical application and services that you render. If you leverage the concept of SDN, that can be achieved, and it can be achieved very well to have you enjoy quality end user experience and improve application performance. Like I mentioned earlier as well, IT agility is very, very key. It's a very key factor. And SDN will allow us leverage IT agility. Your infrastructure will be agile. Just like VM migration or VM mobility, like I explained, that came into the compute world, IT agility would allow for a better way to respond or to act in certain given instances. The traditional way of networking is so slow to changing, so slow in response to the new sets of needs and wants that the network would be having or has. SDN is going to make the architecture or the infrastructure as agile as you can ever possibly imagine. SDN brings agility in the concept or in the form of DevOps, what the DevOps or how the DevOps looks at their function. The DevOps, I don't want to take so much of our time, but DevOps in a nutshell is you constantly looking for how to better develop your processes internally. And there is nothing wrong, or it will be a big gain for an institution, an enterprise, to have DevOps even entered into the cores of the network, so that the network can be as responsive, as agile, as lean, and as effective as possible. Now, there are three ways you can go about this. The level of adoption we can take, or the routes we can use to adopt SDN. We can choose to do the big bang approach, but of course, from the business side, there has to be considerations. We can't go big bang. You could go big bang if it's a greenfield, if you're looking to set up another arm of the business and leverage such, fine. But if you're not, then it therefore means you have already existing infrastructure, a brownfield environment. That brownfield environment would critically leverage overlay technologies. The technologies that you will leverage on top of your current traditional architecture that you will still be able to do to a degree some form of SDN. Maybe not total SDN, because SDN has different portions of itself. There is the SD access, there is the SD1, there is the SDDC, there is so many portions of the network, of the infrastructure, has its own rendition of SDN. But because we might not be able to go at it with a big bang approach, then of course we can begin to leverage overlay technology that will sit on top of what you have. So what you have will now be the underlay network architecture. We will leverage overlay technologies to deliver SDN. Such overlay technologies are things like VXLAN. Different OEM has their own coloration and flavor of VXLAN, or some competing protocols to VXLAN. But of course, industry standard VXLAN is industry standard, and VXLAN can serve very well as an overlay technology to run your SDN architecture. Then there are these vendor-specific solutions. Every different OEM has their own. Juniper calls theirs, I think, Contrail. Cisco calls theirs ACI, application-centric infrastructure. VMware calls their own NXX. Different rendition. Those ones do different. They do it in their different ways. But the last portion will be to do the white boxing, which primarily is what VMware is the line VMware is planning to tow, or is already towing. They say, get your white box switches, get your servers, and we will run all those network functions as services. They will virtualize those network functions. I think this will make us understand one of the really good use cases of business justifications of our network device, of SDN. It therefore means that SDN could help us reduce services like load balancing, network load balancing, for instance. We could reduce that to a service and run the service in different parts of the network as we like. It challenges the core principles, the fundamental principles of networking as we know it. Using white box deployments, we could really push the limits of the network. This is about the entire thing. We have tested a couple of these different OEM flavors, different OEM colorations of the solution, and we can tell you for free that SDN is the way to go. SDN will allow us really enjoy being in an era where we are making everything smart, where our network can be virtualized. SDN is like a competing, or is similar to other concepts or other ideas. There are other ideas similar to SDN. There is the network virtualization. There is the network function virtualization. Those two majorly are more pronounced in the ISP space. But of course, we can still leverage those, and some flavor or some coloration of SDN adopts the principles behind network function virtualization, and as well network virtualization. It's reimagining the way we are doing things now to better the right word to use is basically you're more agile, you're adaptive, and you're able to adjust to the demands of this new era that we are being ushered into by the digital transformation the globe or the world is experiencing presently. This is the point where I welcome questions, and if you need clarifications, if I was too technical, forgive me. I'm sure that in subsequent webinars, I will be able to break down for the business and business inclined attendees more business focused ideas or derivatives of SDN. But questions, comments, additions, disagreements, criticisms, welcome.
Okay, so I don't know if you have questions, you can just type it. There's a question icon. You can just type the questions, we'll take questions. However, this so at the end of the webinar, this slides, the link to download the slides will be sent to you, and a contact email address will also be sent to you, so we can engage further, we can discuss further and all. Okay, so in the absence of questions, this video will call it a wrap, and you will hear from us after now, and I will continue to engage you to discuss SDN. Yeah, so thank you very much, and do have a nice day ahead. Bye-bye.